All right, welcome back. In this video, we'll look at another example of a function and its inverse, example 1.1.2. I'm going to look at the exponential function and its inverse, which is the natural log. So I'm picking base e here just because that's the one that's most important in Cal. I know it's not your favorite, but let's play a tiny bit with it. I want to evaluate two values. I want to evaluate log of e and ln of 1. So ln of 1, well, let's look at this here. I'm going to have to write 1 as the function g applied to something. So if I apply the function g to 0, I get 1, so ln of 1 is 0. And then the same thing here. To get ln of e, I have to apply the function e to something. So e to the something should be equal to e. Yep. 1 would work, and so ln of e is 1. So when I ask you for ln of x, I'm really asking you to figure out how to write x as e to the something. And whatever that something is here, that's going to be your answer. All right, let's look at these two graphs at e to the x and log of x. We need to know them because they're useful in computing limits. We have 2 points, so we know this is going to be e to the x. We know it contains the point 0, 1, and if I go to 1, it's going to be e, so let's put it a bit higher. E is higher than 2, so let's put it here. 1e, and then you should know that it skims the x-axis because it has a horizontal asymptote. And then the same thing that we did to go from x cubed to cube root of x, we're going to do here. All we have to do is to switch the order. So instead of 0, 1, we'll have 1, 0. And instead of 1e, we'll have e1. And so the inverse will, instead of skimming the x-axis, it's going to skim the y-axis and then look like this. All right, if you're having trouble going from one to the other, if you're having trouble seeing the reflection, ask me in class. And I have a trick, but I can't do it on an iPad. I'll show you in person, all right? So again, AB is on one graph. That implies that BA is on the other. And then second thing that you should notice is, what did I write it? We get, all right, I hoped I had found a shorter way. So we get from one graph to the other by flipping, by reflecting. Across y equals x. Right, so let me draw y equals x. And so if we flip it across, we'll get this. All right, now I wanted to look at the domain and the range because that's something that we'll have to do for inverse trig function. And it's more interesting here than in the cube where both were r. All right, so here the domain of e to the x. E to the x makes sense for all value of x, and you could see it, right? Every value of x is hit. If I look at the range, so these are the values of y that are hit. Well, if I look at this, I'm not hitting every value of y. I'm only hitting the positive one. I'm not even hitting 0. I'm skimming 0, but I will never actually touch it. So from 0 to plus infinity. All right, now let's look at ln of x. If I'm looking at the domain, those are the x values that I'm allowed to take. I'm only allowed to take these on that side. There's no graph on this side. All right, so the domain of ln of x is 0 to plus infinity, and the range of ln of x, those are the y values that the function attains. And if you notice, I can go negative, I can go positive, it keeps going, and so the range is r. All right, so one thing that you should notice looking at this, we're switching x and y when we're looking at the inverse. And since the domain are x's and the range are y, we're switching them. So let's write that the range of f is the domain of g and vice versa. All right, in the next video, we'll be recapping everything we've learned in this example, in example 1.1.2, and in the last example, example 1.1.1.